Um, Hi and welcome to another event. Today's discussion is on um, ML Ops. Uh, what is ML Ops? We will quickly cover the 5 slides, which um, details the understanding of what is machine learning and what is machine learning operations. Um, Before we look at a particular technology that we can use to perform operationalize machine learning models. Now, ML Ops combines machine learning and DevOps. So DevOps is another subject um, with regards to continuous integration and continuous development and building pipelines which serves the continuous integration and continuous development of models. So ML Ops bridges machine learning and DevOps. So MLOps, short for machine learning operations, is a practice that combines the principles of machine learning and software engineering. It focuses on the lifecycle management of machine learning models, including their development, deployment, and maintenance. Um, it is very important to understand the life cycle of a building a machine learning model from the very first stage of importing and working with a data set to uh, exploring and cleaning the data set to transforming and engineering the data set to prepare the model for training and evaluating the model and deploying the model for production, right? So the entire life cycle uh, flow is important under the concept of machine learning operations and is a practice which combines the principles of machine learning, the life cycle of a machine, how to build a machine learning model, and also combines software engineering techniques. It focuses on the lifecycle management of machine learning models, including their development, deployment, and maintenance. In the context of machine learning lifecycle, from the very first stage of exploring and transforming the data set to splitting the data set and uh, training and evaluating and preparing the model for production, right? So, and maintaining the model in production, continuously updating the model with new data set which is trained, right? So, the entire process of continuous integration, continuous development with respect to machine learning model is what uh, uh, defines machine learning operation or MLOps in other terms. So, what are the benefits of MLOps? MLOps offers several benefits, including improved model performance, increased stability, reproducibility, and easier collaboration among data scientists and software engineers. It helps streamline the deployment process and ensures the reliability and efficiency of machine learning models in production environments. Now, clearly, the benefits of MLOps helps data engineers, data scientists, machine learning engineers, or even software engineers to monitor the model which is in production and continuously integrate and backtrack with the latest version of the prepared and evaluated data, which will be again redeployed and integrated with the production model to serve the requirements of the client, right, or serve the business needs. So it clearly helps in streamlining the deployment process and ensures the reliability and efficiency of machine learning models in production environment, right? So looking beyond working with Jupyter environment notebooks or Jupyter Colab environments, where we perform analysis and evaluation and prediction of our trained model on unseen data at a local state. Now, if you're looking to deploy the model which is evaluated and trained onto a production level with the help of Docker or any server providers for deployment in production. Like, we have the cloud platforms which serve various services for maintaining models in production and monitoring them. So the entire process of maintaining and monitoring the uh, machine learning pipeline model, and locally, not just locally, but also on the cloud environment, is supported by various cloud platforms like Google Cloud Platform, Amazon AWS, Microsoft Azure, right? And also we have MLflow by Databricks. So another technology platform provided by Databricks, which is MLflow, which can be integrated with your Python API to build a pipeline from where you source the data, to pre-process, clean, transform the data, to evaluate, split, train, evaluate, and measure the performance of your model, to finally deploying the model to, after cross-validation and hyperparameter tuning to serve the model in production, right? Which will help serve various requirements for the business. So the entire process of streamlining the model from the very initial stage to the last stage of deployment is taken care by the machine learning ops uh, frameworks, right? So the various frameworks provided by various technology providers out there, from Google to Amazon to Microsoft, and also MLflow by Databricks. What are the key components of machine learning operations? Key components of machine learning operations consist of various components such as version control for models and code, continuous integration, continuous deployment, automated testing, monitoring, and feedback loops. It also involves infrastructure management and ensuring model interpretability and governance. So clearly, the various components which come under machine learning operations are version control and code, right? For code, for pre-processing the data, for splitting and training and evaluating the model is done with the help of Python modules. A version control software to backtrack the history of your work, to navigate between the different versions of your project, keep a track, and continuous integration, continuous deployment, deals with, uh, you know, a model which is already being served in production to continuously integrate and deploy with additional data which is trained, and improve the performance of the model in time, right? By having it to compare with various versions of the model being deployed and selecting the best model which serves the requirement in production, and continuously integrating and improving the performance of the model by adding more data, by uh, cross-validation, hyperparameter tuning in the pipeline, right? So the various components involved: automated testing, monitoring, feedback loops. Yes, part of the process. It also involves infrastructure management and ensuring model interpretability and governance, right? So to interpret and explore the evaluation of your models, we can backtrack to different experiments which have been executed by the machine learning operations pipeline with respect to different models or algorithms with different parameters, and comparing various models with various parameters to evaluate the best model for production, and continuously integrating and improving the model's performance by adding more data which is continuously sourced right into the pipeline. So these are the key components. Now, what are the challenges in implementing MLOps? Implementing MLOps can present challenges, including data management and quality, reproducibility of experiments, selecting appropriate infrastructure, maintaining model performance, and aligning the processes between data science and IT teams. Addressing these challenges is crucial for successful MLOps implementation, right? So going back to the reference where we are moving from developing a model locally on our Jupyter environment to developing a model on our cloud environment, preferably Google Cloud Platform or any other cloud sourcing platform. And the transition from a local to remote location will enhance the monitoring and deployment process. reproducing the experiment in the pipeline on the cloud, as the data is streamed directly to a warehouse, data storage warehouse on the cloud, which can be used to process and transform the data attributes to the necessary model, which can be trained and evaluated and tested on the unseen data, and can be deployed into production for serving business needs, right? And continuously improving and integrating and developing or backtracking can be maintained and monitored on the various infrastructure that you select for the implementation of your problem, or for the implementation of a building a data analytical MLOps pipeline. Right, so some key challenges, selecting the infrastructure is very important. Different service providers have different technologies that we can work with to implement MLOps. Quality of our data, very important, right? Data quality plays a very important role in building a data science, data analytical model. Maintaining the model's performance, continuously integrating and evaluating the model's performance, improving the model's performance by validation and hyperparameter tuning, comparing various models, which serves the best, performance with the unseen data, and aligning the process between data science and teams. Addressing these challenges is crucial for successful MLOps implementation. Okay. Now, as I mentioned earlier, the implementation of MLOps can be taken care by different technology service providers. MLflow is a very popular framework that we can use to build open source data analytical machine learning operation pipelines. It is provided by Databricks Community. It's clearly an open source platform for machine learning lifecycle. Works with any machine learning library language and existing code. So if you are familiar with Python's sklearn, TensorFlow, PyTorch, right? The popular modules for working with machine learning in Python are scikit-learn and TensorFlow. So, if you're familiar with the programming languages in Python and its various modules, you can integrate MLflow in the Python API. Runs the same way in any cloud, right? So you can deploy your model application with the help of Docker, where you containerize the application into an image and deploy the image onto any cloud function, which is more or less a serverless technology which serves the application, right? So, for example, in Google Cloud Platform, you have something called as a service called as Google Cloud Function, which is a serverless technology to run serverless applications, at a remote location, right? So if you want to continuously serve your application model built locally on the remote or in production, you can deploy it using Docker with the help of Google Cloud Function, which serves your application as a serverless technology, right? So designed to scale, from a single user to large organization, scales to big data with Apache Spark as well. So when you are starting to working with large scale data frames or unstructured data like images, text, audio, video, such big data technologies, you can integrate MLflow with Apache Spark as well. So clearly MLflow has its advantages with building analytical machine learning pipelines on the cloud. It can be integrated with a Python language, with a programming language, preferably Python, and can also scale to big data applications, right? And can be integrated with Apache Spark, a popular framework for working with big data systems. So MLflow is an open source platform to manage the ML lifecycle, including experimentation, reproducibility, deployment, and a central model registry. So it's very important to understand that MLflow, as we understand, is a technology to build ML operationalization applications. Clearly an open source platform to manage the lifecycle of building an ML model, including experimentation. So experimentation, it talks about experimenting the model with different parameters and evaluating the data training with various classifiers or different approaches of algorithms available in machine learning, right? So you have supervised learning algorithms, unsupervised learning algorithms. So different experimentation includes experimenting the data with different algorithms and experimenting the algorithms with different parameters and cross validation to evaluate out of the multiple experiments that we do on the data, which is the best experimented model with the best set of parameters, which evaluates the unseen data with highest accuracy and precision, right? Giving an overall good performance on unseen data, right? So that is with experimentation. Reproducibility and deployment. So, uh, use the model which has been built to test unseen data the um, on the cloud or on your system locally, and eventually deploy the model which is built to serve in real-time use cases, right? And a central model registry. So central model registry behaves more or less like a storage platform which keeps a track of all the experiments which has been done with on the data set, right? So from the very initial experiment to the last experiment with all the different algorithms that have been applied in every experiment on the data is backtracked and served as a version control in the model registry, right? So you can store, annotate, and discover and manage models in a central repository. So the repository will contain all the revisions of backtracked, experiments saved with its performance metrics as a registry component. Okay. So MLflow keeps the entire track, behaves like a version control, just like GitHub, where it keeps a track of all of your previous experimentations with its performance metrics, the results, the best parameters, and how it is performed on the unseen data. So the flow tracking and registry go hand in hand. Okay, so flow tracking is more or less with the code, and the kind of configurations that you set with the code base and with your data to go in hand with the backtracking version of your model. MLflow projects packaging data science code into a format to reproduce on any platform. MLflow models deploy machine learning models in a diverse serving environment. Okay, so clearly, as you can see, MLflow has its capability integrations with various technologies, right? The TensorFlow, scikit-learn, Python, and many more, Hugging Face, Tag Hub. Many organizations also contribute to MLflow, right? So this is definitely the place to get started if you are looking to transition your career into machine learning operations and how to maintain and monitor machine learning models in production with the concept of continuous integration and continuous development. So I just wanted to show you guys a quick start guide. I hope this image talks about everything that we just discussed. A data lake is nothing but a data warehouse where the data is stored, right? A cloud storage platform, a cloud storage where the data is stored. We prepare and explore and prepare the data for training and testing. We evaluate the model, right? On unseen data, we continuously update with hyperparameter tuning and cross validation. We serve the model which serves the best performance after multiple experiments to the model registry, right? So the model registry is where we deploy the model, the model which is after experimenting and comparing with different other classifiers and algorithms. The best model which is selected based on its performance after hyperparameter tuning and cross validation is served to the model registry where it is deployed to monitor and serve the use cases of the business needs, right? Now, this is again continuously integrated and continuously developed because more data that comes in, more data is available to train and test. And it'll improve the overall performance of the model, and the new model which is trained with new data which is sourced into the data lake will be again will upgrade the pre-existing model with the new model, right? Because the new model now has a better accuracy performance in comparison to the previous model. So this when in that case you will continuously integrate and update the previous model which is deployed with the new model as new data is coming into the data lake, right? As a data warehouse. So this is an end-to-end life cycle of machine learning operations, and how MLflow as a framework will help to operationalize this life cycle. Okay, so it's important that if let me maybe share this link in the chat. Okay, anyone looking to explore MLOps with using the framework MLflow, I would recommend to definitely look up this link. Right, so by browsing through this link, you clearly will be able to pip install MLflow, track MLflow in your code. View runs and experiments in MLflow tracking UI. So MLflow will provide you an UI which you can serve at your local host, by selecting a desired port number, where you can keep a track of all the experiments which has been taking place with your model. Run a tracking server to share the result with others. Use Databricks to store your results. Store the model produced by your runs. Load the model from a previous run for inference. So as a data scientist, your explorations involve running your evolving training code many times. MLflow tracking allows you to record important information you run, review and compare it with other runs, and share results with others. As an ML engineer or MLOps professional, it allows you to compare, share, and deploy the best models produced by the team. Clearly. Now, from what we discussed from the presentation, it clearly illustrates these key points. Okay, make sure you guys people install MLflow, right? Add MLflow to your code. You guys, you can look at this example here, where this example imports MLflow, importing train test space from sklearn module, importing a built-in data set diabetes, right? So this is a classification problem. So the classification algorithm that we're using is a random forest regressor. So diabetes, okay, so since they are using a regressor, I believe the target for this data set is continuously changing. So this data set contains a continuous target, which is why this example uses a regressor algorithm instead of a classifier. Okay, splitting the data set into X and Y, training and testing, and creating this random forest regressor, which will train the X against the Y, and finally make a prediction on the X text. That is a model which has been trained, evaluate the model's performance on the testing data. So with respect to MLflow, there are these important attributes that you need to understand, right? So you have something called as a log parameter, which keeps a log of your parameters. You have log metric, which keeps a log of your metrics for the problem. So for example, for a classification problem, you have metrics like precision, recall, misclassification rate, various others. You have accuracy, you have few other metrics, right? Like the AOC ROC curve to determine the performance of your model, your confusion matrix, and various other metrics that you can fetch from the confusion matrix. right? So and in the case of a regression problem, you have the mean square error, the root mean square error, mean absolute error, right? So for every experimentation, the ML flow framework keeps a track of the metrics along with the parameters, right? So artifacts is nothing but the output of every model, right? On the unseen data, the performance of the model on the unseen data is logged in the artifacts registry. Log image and log text adds in additional information, right? The files produced by the run, like the output of the model. Metrics is nothing but the values updated during the run, like accuracy, precision, mean square error. Parameters are the various parameters, right? In hyperparameter tuning, you use various parameters, right? So similarly, the same logic. Right. So if on running this program, and it will create, it will store all of these information in the respective attributes, right? So all the parameters will be inside the log parameters, all the metrics values will be inside the log metrics, and the output of the files will be inside the artifacts. Okay, so a login artifact, which is nothing but an output file, right? So again, please make sure to copy this code on your environment and test run at your local machine to understand the process. To view the ML runs and experiments, you have to run the command MLflow UI. So this will create a local host on your browser, right? You can navigate to the local host with the desired port number that you set in your browser, and you can see a UI where it keeps a revision control of all the previous experiments with the respective logs of parameters and respective logs of artifacts and respective logs of the metrics, right? So this MLflow UI, when you run this on the terminal, right? So when you run this on the terminal, you will be able to see this localhost UI, which showcases the various runs which has taken place with respect to the model, the different experiments. With each experiment, what is the best performance of the model, what is the best parameters that have been selected, and things like that. Right. So you have description. So when you look at the model for a particular experiment, it will have a certain set of parameters, certain metrics, tags, and artifacts. Right. You can visualize all of this using the MLflow UI. Right, so this is really powerful because you don't need to, build all of these information from scratch using Python code. Instead, use the MLflow framework, which will give you insights on your model's performance, right, in real time, and eventually serve the model to the deployment part where you serve it in production for various use cases, right? So MLflow is a really powerful framework for operationalizing your machine learning models. I would definitely recommend all of you to get started with this documentation. I will share this as well in the chat. All right, great. All right, so I hope this introduction to MLflow and the guide to start performing or start building machine learning models using MLflow framework, helps you in your journey as a machine learning engineer or as a data scientist, right? I know I have not touched into details about the MLflow framework, but a guide is what I wanted to focus on in today's session to get you guys started into where to explore the concept of MLOps and using the help of MLflow framework, how you can benefit the concept of MLOps in real time. I hope this event was informative at a very high level. Please dive into the subject at your end and feel free to communicate your questions or doubts or anything in the Nestria Discord server.